Hi everyone, today in Integrated Math 2 we're going to go over Chapter 10, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over what a geometric mean is. When the geometric means of a proportion are the same number, that number is called the geometric mean of extremes. The geometric mean between two numbers is the positive square root of their product. So as you can see, the A and B, which are in red, are the extremes, and the X in blue are the means. So in our case, we have, I'm going to put this to the side here, A divided by X is equal to X divided by B. What you're going to do here is a cross product property. So X times X is X squared, which is equal to A times B. Well, that we can't combine. And we want to solve for X. In order to undo this square, we need to square root both sides. And then that gets rid of the square root. We are then left with X is equal to the square root of A times B, which is what you see right here. So let's look at the example they gave us here. The geometric mean of A is equal to 9 and B is equal to 4 is 6. So let's find out why that is. So our extreme is going to be A, which is 9. So 9 divided by X, which is equal to X divided by our B is 4. So once again, we have X squared, which is equal to 9 times 4, which is 36. Square root both sides to get rid of that square. Then we find out X is equal to 6, which is what we said earlier. And I know that because 36 is 6 times 6, the 6's come out of the square root because there's two of them. So here we have a right triangle, and we know that because it has that little box here, which means 90 degrees. And then if I move this slider over just a little bit, you're going to see it makes this line. Oops. This line right here. This line that we see right here is called an altitude. The altitude of a triangle is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. So if I just move this a little bit more, I have my perpendicular that we were just talking about. So inside this triangle, this right triangle, I have this yellow right triangle and this green right triangle. And as you see here, they share those angles as well. So we have similar right triangles. Alright, so here we have theorem 10.1, and that name's not really important. What's important is that you actually understand the theorem. Just as we were saying before, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So, in our case, for this right triangle, for our triangle ACB, our altitude is going to be CD that we're going to be creating, and there's that 90. That's the only spot that's going to give us that. And our hypotenuse is going to be AD. Remember, hypotenuse is always the largest side of your triangle. So if we have that we know that triangle ACD, which is this one here, or in the red here, is similar to triangle ABC. So think about it, it's this little piece, and then we have this big triangle in there, and they're similar. With that, we also know that triangle CBD is similar to the large triangle as well, ABC. And last but not least, we have triangle ACD is similar to triangle CDE. BD. Then we have geometric mean, or also known as the altitude theorem. The altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of its altitude is the geometric mean between the lengths of these two segments. So our example here, we have the altitude of CD, which is the altitude to the hypotenuse of AB, because we have a right triangle. If we know this, then we can say H can be divided by H, which will be equal to H divided by Y. So I'm going to rewrite this. Once again, you're going to do the cross product property here, which is H squared, and X times Y is X times Y. We don't want the square, we only want to know what H is equal to. Square root both sides, that gets rid of the square root. H is equal to the square root of X times Y. And there we go. Then we have the geometric mean, or also known as the Lake theorem. The altitude drawn to the hypotenuse of the right triangle separates the hypotenuse into two segments. The length of the leg of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So once again, we have triangle ACB, and our altitude is CD to the hypotenuse of this triangle, which is AB. So if we know that, then we can say that C can be divided by B, which is equal to B divided by X. And I'll just once again show you how they get to these answers here. So C divided by B is equal to B divided by X. C times X is C times X. B times B is B squared. I don't want that squared. Square root both sides. And B is equal to the square root of C times X, which is what you found in what you see here. But we also know that CA, so CA, we also know that C divided by A is equal to A divided by Y. So C divided by A is equal to A divided by Y. Then we have A times A is A squared, which is equal to C times Y, C times Y. Square root both sides. That goes away. A is equal to the square root of C times Y. So here we have our triangle here, and our other triangle here, and our large triangle here, which are all similar to each other. And here's the little proofs as well if you want to see those and how that works. And it doesn't matter, even if I change my triangle, the proof's not going to change because it's a general formula. And there we go.